Hello everyone. In this problem, we are given that a new bank account is set up that pays an APR or annual percent rate of 5.1% compounded monthly. And if we contribute $150 per month for 15 years in that account, how much will be the account balance at the end of that time? Now, this is an annuity setup because a payment is being made in that account at regular intervals. In this case, $150 is being deposited every month, so that's why it's in case of annuity. It is not a lump sum amount setup. So that's the first thing we have to understand. Now here we have to calculate how much will be the account balance at the end of the 15 years. So that means we have to calculate the future value of annuity. Now for this, we can assume it to be an ordinary annuity. That means the monthly amount is being deposited at the end of the months. So we'll use the formula for future value of ordinary annuity. So I'll write the formula on the board. So the formula is FV equals, so A, which is the regular amount, times 1 plus R power N T minus 1 over R over N. So let's go over the variables in this formula. Now in this formula, FV represents the future value. A represents the regular amount that is being deposited. A value here is $150. Now the next variable is R, which represents the annual interest rate. And in this case, the given annual interest rate is 5.1%. Now in this formula, we'll use the interest rate in decimal form. So we'll have to convert this percent to decimal by dividing it by 100. So I get 0.051. N here represents the compounding frequency factor. The amount is compounded monthly. So that means the frequency factor is 12 because there are 12 months in a year. And the next variable is T, which represents the time in years. So in this case, the deposits are made for 15 years, so T equals 15. So these are the values of the variables in this formula. In the next step, we can sub in these values in this formula to calculate the future value of the annuity. So we start with the left side. So left side is just FV. We know that A is 150, then brackets and parentheses 1 plus. Now the interest rate in decimal form is 0.051 over 12, and then close the parentheses. The exponent is 12 times 15 minus 1, and then we close the brackets, over 0.051 over 12. Now we have to simplify this expression. Now in order to simplify this expression, we start by simplifying the terms in the parentheses. 150 stays the same, and then I get 1 plus 0.00425. Now we can also simplify the exponent. We can do 12 times 15, which is equal to 180 minus 1, and then close the brackets, and in the denominator we can change the fraction to 0.00425. We'll add the terms in the parentheses. So we get 150, so that stays the same. And then 1.00425 to the power 180 minus 1 over 0.00425. We can evaluate 1.00425 to the power 180. So I get 150 stays the same. Now I'll keep the exact answer so that my final answer is exact. We should only round the final answer. So minus 1 over 0.00425. Now in the next step, we can subtract the terms in the brackets in the numerator. So I got 1.145513604 over 0.00425. So now we can move the calculations here. Now we can multiply 150 by 1.145513604. So I got 171.827047 over 0.00425. We can just do this division to get our final answer. So I got 40429. Now since we are calculating a dollar value, we should round our answer to the nearest cent. So that's 2 decimal places. 8, 9. This should be the final answer for the future value of this annuity. So I hope you'll find this video useful. Please share it, like it, and subscribe to my channel. Thank you very much and have a nice day. Bye.